The next sensor we're going to put in is the digital thermometer, which is the little Dallas digital thermometer chip. It also needs a 4.7k resistor because the actual protocol is I2C that it runs on, but the pickaxe has a nice little reader command so that you can actually stick this on its own separate input and it will read it in and actually convert that straight into a temperature. So we'll solder that in and then we'll run a piece of software down and actually check that it's running. Right, so we've put the temperature chip in there and the 4.7k resistor that goes with it. I've also taken the opportunity to put all the 0-volt connectors in, partly because they actually connect the power and the 0 volts around the board. It used to fool me for a long time why manufacturers actually had a 0-volt resistor. To what purpose could it serve? And then I realised that if you were struggling with a board and you needed to go from one place to another with a wire, it was nearly impossible for a pick and place machine to actually put a piece of wire in, but the one thing it could do was put a component in, hence the creation of the 0-value resistor, which really is just a piece of wire. And so I've gone down the route of using them because they do look a lot neater. To the untrained eye it does look like it's a component on the board, as opposed to a wire which actually looks like you've made a mistake. Or to anybody who's semi-professional will know that you've had a problem and you've had to work around it. Now then, because we're purposefully sticking to a single-sided board, again for the price and the fact that you don't need to do any location, to be able to do jump outs and jump acrosses, I have had to do 5 at the end that I had no choice about, but it does mean that the whole thing does look a lot more tidy.